This is some summary statistics from two measures of expression from two genes. And if you assume you want to compare the expression levels, the first question is what test do you think you would use? Certainly I think from that you couldn't be sure that it was normally distributed. If you had some other data that showed it was, then you could be a bit more confident about using the unpaired t-test. But if you didn't and you really thought, I don't know if this data is normal or not, then that would be the Mann-Whitney U-test would be the one to think about. Another example, you've got paired data. You've got an intervention and gene expression is measured before and after an intervention on just one group of data. And there's various histograms here, a histogram of the measurements before, the measurements after, and then a histogram of the difference. So which test would you think for that data? The key thing is this difference. If that was normally distributed, you could use the t-test regardless of what these look like, but it's the difference that you want to be normally distributed, but it's not in this case. So Wilcoxon signed rank test for that example. And if you've got 4 groups of mice and they've each got a different genotype and you wanted to compare them, which tests would you consider for that? This is just a general question, I haven't got any data. Yeah, that's right, Kruskal-Wallis test, if the data, the residuals weren't normally distributed. This is just about reporting p-values. I'll just go through this quickly. So if you had a p-value came out of your package looking like that, would you report that, or what would you report? So that's non-significance, which is usually abbreviated by NS, or you could use another symbol. So this value, would you put significant? It is significant. I would just suggest abbreviating it so that it's rounded up. You could just put 1 star if you wanted to. What about this very significant result? Yeah, I think the less than a small number is probably a good one to use. But usually people only go up to 3 stars, so but you could, start a new convention. That's the next one. You can either put not significant, or if I sometimes, if they're a bit borderline, put the actual p-value, but always rounded a bit. Right, yep. This one. Yep. The next one. In this case, I tend to sort of put the round up and put the exact value, right, but you could alternatively, well, it's actually, you could say it was less than 0.001, but it's probably better to. Yeah. This one? Do you think that's significant? But it's not less than 0.05. Well, yeah, that's the problem. If you round it, it looks as if it's significant, but it isn't significant. So I think I would probably give 0.54 just so they're sure it's not significant, because if you put 0.05, it's a bit misleading. Because it's not truly significant. And the final one, yeah, I either just put it's not significant if you want to give people a hint that it was a bit borderline, round to just one significant figure, so 0.08. Good, well, I hope that was reasonably easy. Last question's just looking at different scenarios. So you've done an analysis, you've here done a t-test to compare groups A and B, different genotypes, come up with this p-value of 0.042. So what could you say about, what could you conclude? Could you conclude that if you repeated the experiment, the difference would be within this confidence interval? That's the 95% confidence interval for the difference. So would you be sure that your difference would be within that? Is that what that confidence interval's telling you? Yeah, you're not absolutely sure, but you're 95% sure. The next statement, there's a 4.2% probability that the groups are the same. Is that true? Yes, it's true. And we've got a p-value of 0.042, and that's exactly what it means. There's a 0.042 or a 4.2% chance that the groups are the same. Measurements on gene B are statistically significantly higher than those on gene A. Can we say that? The yeses are right, because we've got a significant p-value there, so we can actually conclude that. The last thing, if the experiment was repeated, a significant result would be found again.
19 times out of 20.
Well, actually 19 times out of 20 we would get that gene B was higher than gene A, but not necessarily a significant result. So we might do, but we might not. We're quite likely to, because we've had one once before. But what that p-value is telling us is not probability of getting a significant result, but just that gene B is going to be a higher value than gene A. It might be that, gene B was 38 and gene A was 37, and so that's true from our p-value, but it probably wouldn't be significant. Another scenario, just suppose the sample size was doubled. What do you think would happen then to the standard error?
Get smaller?
Yes, that's right. And the confidence interval? That's this interval for the difference. Would it change?
It would, but not for more than 3 points, something like that, to each side.
Why 3 points?
Because that's my standard error.
Yeah.
If I repeated, I would have that probability of going.
Well, your standard error would be a bit smaller, so the effect on the confidence interval would, because the confidence interval is the mean difference plus or minus 1.96 times the standard error, so it would actually make a narrower interval. So this would be a bit larger and that would be a bit smaller, and the same would happen to the difference. And what effect, larger sample size, what effect would that have on the p-value? So you'd expect higher significance if all else was equal, if the difference and everything in the standard error was equal, the p-value, the standard error would be smaller, and therefore the p-value would be smaller, and you'd be able to conclude significance with more certainty. Next, if p had been 0.07 from this, what would you report? Would you report no significant difference between the groups was found? Yes, but you might mention that it was a bit borderline. Oh, sorry, yeah, there was a choice, but I think we've got the right one. And you might mention it was almost significant. And you presumably, hopefully, wouldn't think about mentioning the groups were the same, because you haven't got a significant p-value. You haven't proved that. If p had been a lot larger, clearly non-significant, would you adjust your answer at all?
Well, you've already said there's no
Yeah.
difference. You can't say
No, you wouldn't, of course, add that the groups were almost significantly different. So, right, well, that was the practical, so hopefully gave you a bit of a feel for what hypothesis tests are doing.